So the way we look at our drone, we look at it as what is going to be the dollar per square kilometer that is going to cost us to collect the data at a given resolution. And now, how does that translate to a requirement on the drone? It's actually not about endurance at all. It's about range.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 421. How effective are drones in monitoring coastal areas? For that question, we head to Kingston St. Michael in the United Kingdom to talk with Mathieu Johnsson, CEO and founder of Marble. Marble provides maritime monitoring using fleets of high-speed drones. The company's drones are used to monitor coastal areas for illegal fishing, drug trafficking, and human trafficking, providing real-time data to suit clients' needs. Matthew's passion for aerospace began in childhood, influenced by his family of aviators and skydivers. During his aerospace engineering studies, Matt focused intensely on the future of aviation, from flying wings to hydrogen aircraft, often prioritizing personal projects over formal lectures. His dedication continued into his professional career at Airbus, where he converted his workshop into a makeshift bedroom to devote more time to building aircraft. His innovative work on 3D printing drones led him to a role in Airbus's secretive future projects office. Eventually, Matt's ambition to drive change led him to found Marble, where for the past 8 years, his company has been developing technology to deploy drones at sea on a large scale. In this episode of the Drone Radio Show, Matt talks about Marble and the use of drones to monitor coastal areas for a variety of marine situations. But before we hear from Matt, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's the price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. And for a limited time, donate $100 or more and receive an official Drone Radio Show coffee mug. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review and rating on iTunes. It really helps improve the podcast ranking among the many thousands of active podcasts today. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how Marble is using drones to monitor coastal areas for illegal fishing, drug trafficking, and human trafficking. Let's pick up the interview where I asked Matt to introduce himself.
I'm Matt. I'm the founder of Marble. I'm an aircraft designer by trade. I started Marble 6 years ago, and what we do is we sell a service of marine monitoring, and we do that using high-speed drones, so fixed-wing VTOL, equipped with an array of computer vision cameras. And we're at the stage where we've started delivering contracts to a few different countries worldwide.
Matt, can you share what distinguishes Marble from other companies offering similar drone services?
There's probably two aspects. The number one is we are aiming to be much, much, much more affordable than what's out there today for marine monitoring. Because for marine monitoring, the only customers that can afford solutions that are out there, so when I'm thinking solutions that are out there, I'm talking like, ScanEagle, TechEver, these types of solutions, they're designed for defense use cases. And because of this, they're just way too expensive for, small governments or even government agencies that are not defense. So that's, environmental protection, these types of things. And then businesses as well, for them, it's too expensive. So the number one thing, we're trying to be much cheaper. And I guess one of the main ways we do that is by looking at drone operation in a way that is very different from what is being done today. So if you look at drones operations today, they're still very much like bespoke. So one person goes to fly their drone and they do that for a few hours, and then maybe they come back the next day, they do a little bit. It's very far away from the way something like an airline would be run today, where you have, you fly almost 24/7, and long-term drone operation are going to be done the same way. They're going to be done like an airline, where you have like high turnaround and optimal depreciation of the aircraft. So it's kind of like we're building the hardware and the software to be able to have an operation that looks like an airline.
Does Marble conduct the monitoring on behalf of its clients, or do their clients manage the operations themselves?
We provide the service. The reason for it is, I guess I like to use the analogy of operations of satellites. So if you look at the way satellite used to be operated, early on in the industry, is you had to buy your own satellite, put it in space and operate it and depreciate the cost of the data that was collected by the satellite just on your own operation, because the industry was immature and that was the way to do it. The way satellite data collection works today is if you want data, you're not going to buy your own satellite. You're just going to go on a website somewhere and you're going to require a company that already had satellite in space to collect some data for you. And drones inevitably are going to be the same way as well. It's just we're still very early in the industry. And so today, if you want data, you need to go and buy your own drone and operate it a bit like satellites early on. So knowing this, the way forward is going to be a bit more like satellite operation. We're already building for that environment where we will be having the infrastructure of the drones that we're flying, constantly collecting data from multiple users at sea. So, people that want to do a protected area monitoring, or people that want to do border control, or people that want to do like detecting seaweed, will be flying continuously and just selling the data to all those different users at the same time, like from the same data set and the same flying. And if you want to get to that, you want to be the one that operates the drone, not just manufacturing it.
Tell us about the drones, and can you explain why they're particularly suited for marine environments?
The aircraft we've built is a fixed-wing VTOL, which by itself is not really like the most innovative things nowadays. I think it's kind of like commonplace. Now, if you want to do large-scale data collection, you probably want to have fixed-wing VTOL aircraft. I guess what makes it different is the requirements we've built that drones for. If you look at typically when people look at specs of aircraft, probably the main metric they look at is endurance, which is actually not a good metric at all if you're talking about large-scale data collection. Because if you want to do large-scale data collection, the key thing that matters is the square kilometers and the dollar per square kilometer, which is, again, the metric that is used today for if you purchase satellite imagery data, you're looking at the dollar per square kilometer and the resolution. So the way we look at our drone, we look at it as what is going to be the dollar per square kilometer that is going to cost us to collect the data at a given resolution. And now, how does that translate to a requirement on the drone? It's actually not about endurance at all. It's about range, and that's ground range, not air range.
What's the difference?
The difference is really just the wind. The ground range is the effective range your plane's going to be flying above the ground. And the air range is the range that, from the physics perspective, your aircraft's going to travel into the air. So that's, for example, let's say you're on an airliner and you fly between, New York and London, and you have a headwind the whole way. Your plane will be flying more than the distance on the ground on the planet between New York and London, because it will have to travel the extra distance of the wind pushing it away. So your air range is going to be higher than your ground range. So it means that the ground range is the thing that matters when you're collecting data. It's not the air range. And the way you do a good ground range, especially if there's wind, is you actually want to fly really fast, because you want to spend less time in the air. So you're less affected by the fact that the air mass is moving whilst you're in the air. So if you're very slow, you're not going to actually be covering much ground range because you'll be fighting the wind all the time. So what that means is ultimately for our drone, what we've done is we've done a pretty high speed aircraft. So we cruise at 100 miles an hour, which for a 10 kilo fixed wing VTOL is actually, it's probably twice the speed of what systems typically do, maybe even a bit more. So that's how you get a lot of ground range. And the second thing is we've designed a new sensor. So instead of using a gimbal camera, we're using an array of several cameras pointing either side of the plane. So the cameras don't look forward or backwards. They just look sideways. But because you fly really fast, you actually don't need to look forward or backwards. You just collect a lot of data looking sideways far to the horizon, which again is a little bit like you could imagine a satellite. It's actually the same thing. A satellite its sensors don't look forward or backwards because the satellite goes very quickly around the Earth. So you just need to look sideways. Our drone is kind of the same thing. In some ways, like a small, at high speed atmospheric satellite, which is quite different from how drones are envisioned in general nowadays.
Do the drones launch from land-based locations, or are they deployed from ships?
Nowadays, we do it from shore, just because you can imagine solving any of these problems is quite a complex thing, a difficult thing to do. And so we're purposefully narrowing, I guess, the customers we're trying to address. So taking off from a vessel is slightly more complex. So we've decided to focus for now on taking off from land. But if you look at the actual system itself, I've mentioned, we fly fast. And because we fly fast, the drone is very insensitive to wind, which means ultimately taking off from a vessel is something our system is very well suited to do. It's again, like we just have decided for now to exclude it, but it's on the roadmap, it's going to be something that fits our system really well ultimately.
Is there anything about Marble's ground control system that you'd like to highlight?
If we look at the overall system, right, there is the aircraft, there's the ground station equipment, and then you also have where the customer consumes the data you're collecting. Often the ground control station and the location where the customer consumes the data is sometimes the same thing, which means, if you're doing maritime monitoring and you want to see what's happening from the drone, like the data that's coming out, you need to be where the ground station is. And that's quite ineffective. And most customers that we talk to, they don't want to be where the drone's being flown from. They want to be back in their office and seeing the data in real time, that's coming from the drone. Then that's what we've done. We've designed a software that gets the data that comes from the drone to the ground station. From the ground station, it then gets relayed to our servers, and then it's displayed to a customer interface. So that means, again, if you're the head of the police, you can just be in your office, you log into our system, and you get the data coming out of the drone without being where the gun control station is.
The Marble website mentions a software called Ocean View. What is it, and what features does this software provide to your clients?
So Ocean View is that piece of software I was just talking about that is in the overall system, you have aircraft data goes from the aircraft to the ground station, and then it goes to that remote software. That is the software called Ocean View. So what that software does is, one, it gets the data real time from, I think we do have like 1 or 2 seconds of latency between when it gets collected by the drone and being displayed on that website. So number one, it does that. It also merges that with other sources of data. So that might be things like AIS. So AIS is a type of transponder you have on boats, which if you have a boat of a specific size, it's meant to be on, and like it's mandatory that you have it. Doesn't mean that people actually turn it on, obviously, if you're talking about illegal activities, but you can make correlations between the data you collect from the drone and that data. So we have a lot of additional sources like this. We might even be able to implement some radar imagery as well. But mostly it's, the real-time data from the drone. And I mentioned earlier, our drone doesn't use a regular gimbal. It uses an array of cameras that are looking to the side and straight on the drone. And to be able to make use of this data, you need to kind of like stretch it back so that it is displayed as a map. So it's like, imagine if you have a camera looking to the side of your drone, if you were to try to project it on a map, it would look quite deformed, right? Because you're not looking straight up. So we are doing those maths in the background so that as you look aside, it actually reconstructs real time as a map on that software Ocean View. And then on top of it, you can start doing, automated detection of vessels. And so ultimately,
monitoring the ocean seems like a daunting task.
What's interesting today is if you look at the sea, there's very little data we have about the sea because it's very difficult to monitor, right? It's like, I think on the planet, you have 2% of the Earth's surface that is cities, and the sea is 70%. And you can imagine where we mostly fly drones is going to be like, around agriculture and then maybe around like houses. So right now, where we fly drones or where we collect data, it's typically in areas where it's very easy to just have someone going there and fly, a quadcopter or maybe have a camera or something. So it's the places where we collect data typically are like traditionally are very easy to do it from. At sea, where you can't travel like 500 kilometers out and like fly a small quadcopter, it's much harder. So what that means is right now we don't have data about what's happening out at sea, which is where you have piracy and lots of different problems.
What are some of the primary use cases for Marble's marine monitoring services?
The main use cases for us, all the users who today need marine monitoring data but can't afford the traditional defense systems. And that is the vast majority of the market. For example, for satellite imagery today, it's mostly consumed by like businesses or governmental organization. The defense industry uses only a small fraction of actually the total bandwidth collected by satellites. So if you look at our system, it's kind of the same. We're designing it for, even though today only defense people use it because they're only one being able to afford it, we're designing for that much wider market. And so some of the specific examples you might be interested in that we're working on today. It's things like detecting sargassum. So sargassum is a endemic seaweed in the Atlantic. It's used to just basically grow there, stay in the Atlantic thanks to the local currents. And then what happened with global warming is that seaweed started growing more and more. And so last year, I think it's now 72 million tons drifted from the Atlantic to the Caribbean. And that creates problem with the local environment. It actually generates like toxic fumes when it decomposes once it gets to the beach. And also those Caribbean islands, it's terrible for them because it destroys tourism to have that amount of seaweed on the shore.
How can drones help?
There is actually a very big opportunity to go out and collect the seaweed before it reaches the shore. So you would protect the shore this way. It's much cheaper to go pick it up at sea rather than like excavate it from the beach. But the other big benefit with that seaweed is you can actually make biofuels from it. You can also use it to do carbon credits because seaweeds are really good to collect the carbon from the atmosphere when they grow. So if you collect them before they get to the beach and decompose and re-release the carbon, there's actually like an environmental benefit this way. But to be able to do this, you need really good information about where the seaweed is. And the way people that are tackling that problem today do it is they use satellite imagery that is typically 2 or 3 days old. And that does mean that they have to account for current, for wind, to know on like the given day where they go out with the vessel to collect it. They kind of use predictions which tend to not be good. So using a drone, which is long range and large scale enough, because you need to fly like thousands and thousands of square kilometers to detect that seaweed, you can really help them because you tell them real time, okay, there is this seaweed here. It's this, we estimate it's that much volume of seaweed based on the size of the patch and, its color. And that's like a very, very big use case that you can't really do with defense system because defense system would be way too expensive for this. And drones available on the market don't have the performance to do this. So that's like one example. The more traditional one would be, you must have heard of what's happening in Haiti at the minute. And so you have plenty of Caribbean islands next to Haiti that are very worried about having, drug trafficking, weapons trafficking, people trafficking massively increasing in the next few months. And these countries don't have the budget to buy manned aircraft to do border control. So they kind of stuck with using boats. So for example, for countries like this, having a high performance, low cost drone to help them with border control is very useful. And that expands to other areas of the world again, where plenty of countries don't have the budget for defense system, but yet they have the need to control their borders.
Are any of your clients today using Marble for monitoring illegal fishing activities?
The stage at which we're at, we're not yet doing yearly monitoring in one area where we're contracting and we're flying every day. What we've done so far at our stage, because we're still relatively small, is we've operated kind of like on a 1 month basis. So we go somewhere, we use our system, and recently we've started proving that it's effective enough. And in the next few months, we hope to start moving from, a 1 month deployment to a like yearly ongoing deployment. These type of 1 month deployment, we've now done them we've done Africa recently, we've done Southern America, we've done Central America as well last year. And most of these were for actually detection of illegal fishing.
Are these mostly government organizations?
These were all, ultimately the customer was governments, but sometime for some of these countries, it was actually being subsidized. For example, we've done a deployment in Africa where it would actually be a Western country that was paying for our deployment to help a government in Africa that didn't have much budget, and kind of like showing them, look, with a smaller budget, here is this company that can do something for you. And this was actually subsidized by a larger Western country. But yeah, it's been mostly government so far.
Detecting illegal fishing must be challenging. Is it as difficult as finding the needle in a haystack?
There is how we approach it today and how we can do it long term. So I think long term, once we achieve that vision that I'm sure everyone has about, in the future, drone will be fully autonomous. There will be robotic hangars, and they will be flying from those robotic hangars with no pilot supervision. And then when that is the case, I think it will be cheap enough that you could just deploy it everywhere and just go find a needle across the whole coast without having a pre-existing set of information about where that needle might be to kind of like narrow it down. That's long term. Short term, where we're not yet at that vision of, you don't need any pilots and everything's just done by itself automatically. Right now, you still need operators, so it's more expensive. In that setup, the way we do it is we tend to rely on other sources of information to narrow down where we should go and operate. So for example, in Africa, for the operation we've done, it would be that we were working with a partner that would look at satellite imagery. And satellite imagery doesn't give you like a specific, boat, like it doesn't tell you which boat was where, but it can tell you what is the intensity of boat traffic in an area where there shouldn't be a boat traffic in this area. So it kind of like gives you an narrower geographic location where then we go with the drone and then we fly like daily in that location, and we can start saying, okay, this is the specific boat, this is the specific, ID of the boat, and then this is where it comes from. So that's how we narrow it down. Typically it's using satellite imagery.
In terms of illegal fishing, is the problem more of poaching or just not complying with the rules?
Here, it's not necessarily like they're like bandits and they're trying to like make tons of money from like stealing the local fish or whatever. It's usually that they know nobody is following the rules. And so if one of them starts following the rule, they'll just lose their business. And so if you start having a system that is good enough to do daily monitoring, then everyone will actually benefit from the system because they will know that now, okay, I should be following the rule because everyone else around me is following the rule. And so it's still fair competition. So it's not just like trying to police and point the finger at the specific one. Is also creating that system of accountability that I think is exciting.
What challenges have you faced in developing drone technology specifically for maritime surveillance?
It's a super exciting industry to be in at the minute because everything's moving so quickly. So whether it's like, batteries get better, motor get more reliable. But I guess the main difficulty would be that despite those quick changes, it's still very immature, which means that when you're trying to sell a full system to a customer, like, provide them data, there are many, many layers within that system that need to exist for the customer to have his data. So, for example, for marine monitoring, so we've talked about it, you need like a drone, you need a GCS, you need the software, but there's also, you need permits to be able to operate. If you go within the aircraft, there's like the motors, the controllers, the autopilot. There's so many layers into being able to deliver that data. I mean, ultimately, that will be a whole industry with tons of different people specializing onto these layers. But right now, these companies that specialize into different aspects, often they don't exist. So for example, when we're talking about a software for processing our data, we can't go and partner with someone that can do this. We need to build it ourselves because nobody is yet specializing onto this. And that's probably what is the most difficult. As a company who wants to deliver full service, you need to cover lots and lots of different sections because the industry is too immature and those elements don't exist. The best analogy would be, for example, if you build an airliner today, you have tons of manufacturers that will do the bolts, that will do specific seats, entertainment systems, whatever. Like every single component of the aircraft now is, you've had one company specializing on designing just that one part and you just need to source that. But if we were looking 60, 70 years ago, if you were lucky and designing an aircraft back then, a lot of these components you would have to design in-house. And for drones, we're still at that stage. So I guess that's the main thing that is difficult is we have to cover so many of those elements. It's just a very large scope of work.
Are there any unique regulations or specific requirements for operating drones over maritime areas?
It's not really different to when you operate above land. You still, for doing beyond line of sight flying, you still need an exemption. What's interesting though is those exemptions tend to be two things. One, they're a bit easier to get because you're less likely to encounter, general aviation traffic or people that don't have a ADS-B or like some form of transponder on board. You're less likely to encounter them when you fire out at sea at low level because nobody is going to fly with a single engine aircraft, like 400 feet above water, 15 kilometers away from the shore, because if you lose your engine, you're going to ditch. So typically that means there's little traffic above water, so it's easier to get BVLOS permits in general. And the second thing that is interesting when you're flying out at sea is those BVLOS permits, at least in the UK or the operations, the countries where we've gone, they tend to be geographically limited. So you don't get a BVLOS permit in the UK for like the whole country. Obviously, you would get it for like very specific areas. And as a business, it's kind of annoying because it means if you want to operate over a large area, you need more permits. And above land, because the area over which you get those permits is small, you need lots of permits if you want to scale. Whilst at sea, typically when you get one, it's a very large area straight away. So I guess those two things is one, it's easier to get the permit, and two, when you get one, it covers a bigger area. Means that in general, operating drones BVLOS at sea is a bit easier than doing it above land.
Do you need special permissions or exemptions to operate drones over water?
The way you can do BVLOS in the UK is you need to be able to demonstrate there are no other airspace users in that area at the point where you're flying your drone BVLOS. And that's either done by having a danger area that is established. So that might be, like a military airspace that is already reserved for doing weapons practice or something. And because of that, it has been designed to be temporarily closed off when someone's using it. And then as a drone operator, you can actually go and reserve that airspace to the military forces, and they will close it off for you And that's like, it doesn't cost anything. It's literally just like knowing how to do that process. So that's the way number one, which is the best one, is when you already have a danger area this way. The other way is to get a temporary danger area, which in the UK is valid for 90 days. And at that point, you actually need to go and justify why you can close that airspace temporarily. And that's much harder because you need to go and talk to like the local airfields and everything. So that's usually not how people do it above land, because above land, you don't have a lot of existing full permanent danger areas. And so if these are the two options, temporary or like an existing permanent danger area, above sea is actually a lot. I think it's probably 25% of the UK coastal area that is a permanent danger area. And the reason for it is when the military probably set these up, decades ago, they looked at where are people not flying much. And so that's going to be the best place where we can do all our testing. And they went above sea because, again, general aviations, they don't go fly low level above sea. So it's all closed off. So that's why the reason it's easier over to get them and over a large area, what I was saying earlier, and you were asking, is it like a government thing that is in place? It's not. It's literally just historically above sea, you have those danger areas to do military testing, and these are very suitable for flying BVLOS.
What motivated you to create a drone company with a focus on maritime surveillance?
The first portion of the question, which is why did I start a drone company? I started the drone company because I've been in and around planes since I was 2. My dad has a private pilot license, and so I've just always been passionate about aircraft, and early on wanted to be a fighter pilot. I have some eyesight problems, so couldn't do that. So the next best thing was to be an aircraft designer. And so I joined Airbus and specifically got into their future projects department. So that's like the equivalent of Skunkworks. So that's, where they design electric planes or like the planes Airbus might do 30 years from now. It was really hard to get in that department, and actually to get in, that's when I started building drones on the side. That's how I was like, maybe I can, design planes, build them, test them, and demonstrate to that secret department that I'm good enough to be an aircraft designer. And that's how I got really good at designing drones and building them. And then ultimately, when I managed to get in the department, I realized that it might be the most exciting department in Airbus. It's still Airbus. It's still a very big, slow-moving company. And so the most exciting thing for me to do at that point was start a business. So that's why originally I started Marble, was to work on the future of aviation. And the best way to do that was to have a company. And then the question about like why maritime, the reason for why maritime is because amongst all the drone use cases, it's probably the one that benefits the most from high performance aircraft. Because when you want to cover a very large area, like you need to do at sea, the performance is very important. A lot more than when you want to do logistics over like short distances and things, for example. And as I've said also, like from a regulatory standpoint, it's a bit easier to get the permits above sea. So those two reasons were why, like strategically, we decided to do marine monitoring.
Was there a particular moment when you knew maritime surveillance was the way to go? Or was it a gradual decision?
No, it was actually a complete stroke of luck. A friend of a friend was operating drones in a Caribbean island. They were operating drones for one of the typical use case for quadcopters, like taking photos of real estate. That was like maybe 8 years ago. So they were flying those quadcopters to monitor real estates. And one day, that person was contacted by the local police saying, well, we have problem with our border control. Can we try flying your quadcopters to help us monitor the sea? And he was like, oh, okay, yeah, I'll try that. And that person who was flying the quadcopters for real estate was the local expert for drones. So they tried this and obviously quite quickly realized that quadcopters are not great for marine monitoring. The performance is way too limited to do that. And so that person started being on the lookout for, okay, what types of drone would be good for this solution? And that person, turns out we had a friend in common. So we got introduced one day, and then through that, like my technical expertise and his knowledge of that problem, I was like, oh, this is the perfect use case for what we're building. And for him, it was like, wow, what we're building is like the perfect solution. So it was like mostly luck. And then afterwards realized, wow, actually there's lots of reason why this is an interesting area to be in.
Starting and growing a company is challenging. What obstacles did you face in establishing Marble?
Well, I guess very early on, what was difficult was to find the people to work with. So I started the concept of the company whilst I was still employed at Airbus. It wasn't really like a company at that point. It was more like, a side project I was doing in the evening. And it was very easy to get other engineers interested in the problem and coming, in the evening, in my living room. We were building things. There's a big difference between doing this and having people leave their full-time job to start a business. So early on, it was like finding the right partners to start a company, because I was the one happy to leave my job and take a risk. But again, in the aerospace industry, it's not really like a super entrepreneurial area. So it's hard to find those people. That was probably the first difficulty very early on. But once I got started, the thing that was difficult is just, especially in Europe, accessing capital to build a company that is doing hardware and selling to governments, just like two of the things that are the least attractive to investor, because it's very difficult. That was probably like the next big challenge.
What advice would you give to other entrepreneurs?
In general, I would say you want to go build a company in a domain you're super passionate about, because it's going to be very, very difficult, and you're going to need to have a super high level of perseverance. And that perseverance can't just be like just discipline that you tell yourself every day, I'll keep going. I mean, you need that, but behind that, you need to have almost like an irrational drive to want to make something happen. And that's what's going to keep you going when it's tough. So I guess the only way to have that is be really passionate about what you're trying to build. So it might sound a bit boilerplate because it's kind of obvious, but be passionate about what you're trying to build.
What's next for Marble?
We're starting to be way more public about what we're doing, because we've been building the technology in the background over the past 5 or 6 years. And we're going to start to be releasing a lot more information about what we've built, because a lot of the data we have on our website is like outdated, very early prototype from quite a few years ago. And the second thing is, I've mentioned up until now, we've mostly done bespoke, like a few months kind of deployments, but we're on the verge of starting several longer term ones. And that's when it's going to get really exciting, is to do large scale deployments and starting to have like proper meaningful impact with what we've built. So yeah, I would say those two things.
Why did you name your company Marble?
There's two elements on how I came to that name. One was I didn't want to have drone or UAVs or RPAS or in the name, because it feels like vocabulary in the drone space changes every 5 minutes. Like when I started the company in 2016, I think most people, when they were hearing the word drone, they were thinking Reaper and weapons. And today, I think if you say drones, people think quadcopter. So I didn't want to have any of that vocabulary in the name, because I didn't want to be tied up to how that name might be interpreted in the future if vocabulary meaning changes. So no drones in it. And then the other element, obviously having something small and short, and catchy. And the last one was actually having something related to environmental protection in general. Because I mentioned I left Airbus to build this company because I wanted to work on electric planes, the future of aviation, and decarbonization is a big element. So I wanted something in the name that was connected to sustainability. And so that's why Marble specifically, because the name of one of the first photos that was taken of the Earth from space, the name of that picture is the Blue Marble. Can't remember the exact date of when that was taken, but that photo was used a lot in early sustainability discussion, because it was kind of like that, that very visual representation of how the planet is really small relative to the vastness of space. And so, yeah, that photo is the Blue Marble, and that's why the company is named Marble.
And for my final question, Matt, what message would you like to leave regarding the future of the drone industry?
Genuinely, I think it feels over the next 30 years, the whole industry is going to completely change. And I think we're still at the stage where most of the society hasn't realized that. And so, for example, when I think about drones, I think include eVTOLs and air taxi in that whole thing of like the future of aviation. All of these things are going to completely transform society. And again, I don't think it's obvious to general public yet. So I think it's going to be very exciting. Whenever I think about what we're building now at Marble, if I think worst case scenario where maybe we're not successful, I always think that whatever the outcome ends up being, like the knowledge all of us are generating here and we're learning as individuals is going to be carried over into next company and other projects. And I'm very excited to just be in that industry. It feels like a lot of things are going to happen in the next 30 years.
That's it for episode 421 of the Drone Radio Show. I hope you enjoyed hearing from Mathieu Johnsson of Marble Drones. I want to thank Mathieu for taking the time to speak with me. If you want to learn more about Marble or want to connect with Mathieu, check out the webpage at marble.aero. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review on iTunes. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.